Hey science explorers, have you ever wondered why you don't float away when you jump? Or how the moon stays in orbit around Earth? Well, the answer is something we can't see, but is always there: gravity. And today, we're going to uncover the science behind gravitational fields and how objects exert forces on each other even when they're far apart. Stick around, because by the end of this video, you'll understand how gravity is one of the most important forces in the universe.
Hey everyone, I'm Jordan Spivey, joined with my dad,
Spivey, and if you're new to the channel, hit that subscribe button so you don't miss out on any of our awesome science videos. Also, scan the QR code in the top left corner of the screen to contact us and explore more of our awesome content and material.
In today's video, we'll explore how gravitational fields and gravitational forces act on objects. So let's do this.
Our learning target for today is, I will be able to describe and explain how gravitational fields exist between objects exerting forces on each other even when the objects are not in contact with each other.
Gravity is the force that pulls objects towards each other. It's the reason why things fall down instead of floating away. Isaac Newton first described gravity when he saw an apple fall from a tree. He realized that the same force pulling the apple to the ground also keeps the moon in orbit around the Earth. But here's the cool part. Gravity doesn't need objects to be touching to work. For example, imagine you're standing near a campfire. You don't have to touch the fire to feel its heat, right? That's because heat spreads out around the fire. Gravity works in a similar way. Every object with mass creates an invisible gravitational field around it, which extends in all directions. The bigger the object, the stronger its gravitational field. Earth has a much stronger gravitational field than a small rock, and that's why everything falls towards Earth instead of floating into space. Quick checks for understanding. Number 1. What is gravity? Number 2. Why does gravity work even when objects are not touching each other? Number 3. What is the relationship between the size of objects and their gravitational field? Pause the video and take 3 minutes to write your responses. You got this.
Here's something mind-blowing. Gravity isn't just something Earth does to us. We also pull on Earth. That's right, every object with mass pulls on every other object, even if they aren't touching. For example, the moon is pulled toward Earth by gravity, but the moon also pulls on Earth. That's what causes ocean tides. The strength of gravity depends on two things: mass and distance. The more mass an object has, the stronger its gravitational pull. The less mass an object has, the weaker its gravitational pull. Also, the more distance there is between objects, the weaker the gravitational pull is, and vice versa. That's why astronauts weigh less on the moon. The moon has less mass than Earth, so its gravity is weaker. For example, the moon's gravity is only 1/6 that of Earth because its gravitational pull is only 1.62 meters per second squared, while the Earth's gravitational pull is 9.81 meters per second squared. Let's break it down even further. If you weigh 150 pounds on Earth, you would only weigh about 25 pounds on the moon. Imagine how much you would weigh on planets with much larger and smaller gravitational pulls than Earth. Quick checks for understanding. Number 1. Why does the Earth and moon pull on each other? Number 2. What are the two factors that the strength of gravity depends on? Number 3. Why would you weigh less on the moon than you would on Earth? And number 4. If you weigh 180 pounds on Earth, approximately how much would you weigh on the moon? Pause the video and take 5 minutes to write your responses. You got this.
In summary, gravity isn't just on Earth, it's everywhere in the universe. The sun's gravity keeps planets in orbit. Black holes have super strong gravity that even light can't escape, and gravity is what forms stars and galaxies. Without gravity, the universe will be a big, scattered mess. So, now you know gravitational fields exist all around us, even though we can't see them. Gravity is what holds our universe together, and it's at work even when objects aren't touching. Remember, the larger something is, the stronger its gravity. That's why we would weigh more or less on some planets, because some planets have more or less gravitational pull than others. Quick checks for understanding. Number 1. Which planet would you weigh most on? Explain why. Number 2. Which planet not including moons, would you weigh the least on? Explain why. Number 3, why does the moon orbit or move around the Earth instead of the Earth orbiting around the moon? Pause the video and take 4 minutes to write your responses. You got this.
And that's our video for today. Now let's test your knowledge to see how proficient you are with describing and explaining how gravitational fields exist between objects exerting forces on each other, even when the objects are not in contact with each other, by taking our video quiz.
Use your electronic device to scan the QR code at the top right of the screen, or you can click the link in the description box below the video to take the quiz.
Remember, 80% or higher for proficiency. Record your results on your proficiency sheet. And if you don't get it the first time, you better keep going because it's not over until you win.
Don't forget to hit that subscribe button, click that bell icon, and also scan the QR code to contact us and explore more for awesome content and material. Peace, and have a positive, productive day.